Hi students, welcome to Max Point of View. Today we are going to solve each and every theory question which is there in the textbook from the chapter Electricity Part A. Before watching this video, my suggestion is watch the concept video. Then only this video will be easy for you and few questions you can only solve. After solving each and every theory questions, we are going to solve each and every numericals. That video will also be there available in the description box. So now without wasting any time, we'll start with our first question. Write an expression connecting the resistance of a wire and specific resistance of its material. State the meaning of symbols used. Very simple. This we have used earlier, right? This is the expression they are looking for. So we have to write the meaning of the symbols. R, you can write it right. R is nothing but resistance. This symbol, okay, is nothing but resistivity. L is nothing but length of the wire. A is nothing but area of cross section of the wire. That's it. Our next question, state the order of specific resistance of metal, semiconductors and insulators. Okay, what do you mean by order? That means how much resistivity it has. See, very simple. When it comes to metals, they are talking about metals, semiconductor, insulators. Okay. See, in metals, okay, resistivity. See, I'll use the symbols, but in the exam you have to write it in the full form. Resistivity is low. Why it is low? Because current will be high. Okay. Here in semiconductors, resistivity is high because current will be low. Okay, when it comes to insulators, okay, insulators, resistivity is very high because no current will pass through it. That's it. This is nothing but the order of specific resistance or resistivity in metals, semiconductors and insulators. Our next question, name a substance of which the specific resistance remains almost unchanged by increase in temperature. So even though you increase in the temperature, the specific resistance will remain constant for few materials. We have to name those materials. Very simple. Okay, it is constantan and manganese. Okay, manganese, these two are alloys. Okay, these two are alloys. Even though you increase the temperature, the specific resistance remains constant. Our next question, name the material used for filament of the electric bulb and heating element. Okay, listen, there are two questions, right? First we'll talk about filament of electric bulb. So in filament of electric bulb, we'll use tungsten. Okay, tungsten. Why we are using tungsten? Because it has high melting point. If it has high melting point, its specific resistance or resistance will be very less. Next, the material we use it for heating element. As a heating element, see, for heating element we use nichrome wire. Okay, nichrome wire because it has, okay, high specific resistance or high resistance. See, tungsten has high melting point, that means it has low specific resistance. Nichrome wire, why we are using this one in the heating element? Because it has high specific resistance. What do you mean by heating element? That means we need a temperature, to increase the temperature, like water heater. In water heater, what do we require? The heat, the temperature. If the resistance is more, temperature will also be obviously more. That's why we are using nichrome wire, because it has high specific resistance. Our next question, a substance has zero resistance below 1 Kelvin. What do you call those substance as? See, when a substance has zero resistance, that means those are called superconductors. What do you call that as? Superconductors. Define the term current and state its SI unit. What do you mean by current? See, current is nothing but the rate of flow of charges. See, this is how we define current. This is the formula, correct? So, rate of, see, whenever you see anything, any formula divided by time, you can use the word rate, rate of change of. A rate of change of means any quantity divided by time. So, rate of change of, what is this? Q, charges, okay, is called current, is called current. Next, what is the SI unit they are asking? That is nothing but ampere. Okay, capital A is enough to get full marks. Our next question, define the term electric potential, state its SI unit. See, all these things we have learned in concept video. Then now we are going to just answer these questions. See, what do you mean by electric potential? The amount of work done. The amount of work done. See, that is nothing but V only. But electric potential is nothing but V only, voltage. Amount of work done, okay, per unit charge, amount of work done per unit charge by bringing the positive test charge from infinity to a point, from unknown point, infinite point to a, see, from infinity to a point. This is nothing but electric potential. Now, this is how we can define it with a sentence. Our next question, how is the electric potential difference between the 2 points is defined? State its SI unit. Okay, very simple. See, this is similar to the previous question, that is electric potential. See, we can answer with the help of formula. Listen, V is equal to electric potential or potential difference. Now we are talking about potential difference. Potential difference is nothing but amount of work done per unit charge by bringing the positive test charge from one point to other is called potential difference. Electric potential, the same definition, okay, it was from infinite to one point, but here from one point to another point. Both are known points only. The SI unit will be volts. That's it. Our next question, explain the statement the potential difference between 2 points is 1 volt. Very simple question. Using the formula we can aramse answer this question. Listen, to answer this kind of question we need to know the units. Unit of work done is joule and unit of charge is coulomb. See, how can we define it? 1 joule of work done by bringing 1 coulomb of charge. Okay, from one point to another point is nothing but 1 volt potential difference. That's it. Our next question, state whether the current is a scalar quantity or a vector quantity. What does the direction of current convey? We have one more sub question. First we'll solve with respect to the current. Listen, state whether the current is a scalar quantity or a vector quantity. What do you mean by scalar quantity? Scalar quantity means the quantity should have only magnitude, it should not have any direction, correct? So, current, whether it is a scalar or vector, okay, this is very important thing. Current is a scalar quantity. Why? Because it has magnitude but no direction. What do you mean by magnitude? Magnitude is nothing but the number. 5 amperes of current, 3 amperes of current, 2.5 amperes of current. The numbers, those numbers are called magnitude. Okay, then don't you see, whenever we put any arrow mark in the circuit, this represents the direction of current, correct? Then why it is not considered as a vector quantity? Vector quantity is nothing but it has both magnitude and also the direction. We are writing the direction of current in the circuit, but we are telling it is a scalar quantity. Why? Because that is what they are asking. If it is a scalar quantity, what does the direction of current conveys? This direction conveys the flow of electrons will be opposite to the flow of current. That's it. This direction conveys the flow of electrons. The movement of electrons will be opposite to the flow of current. This will not tell us the direction of current, in which path it is flowing. That's it. So current is a scalar quantity. Then we'll go for the second sub question. State whether the potential is a scalar or vector. What does the positive and negative signs of the potential conveys? See, we need to now tell whether potential is nothing but potential difference, or electric potential is nothing but voltage only. Voltage, whether the potential, okay, or voltage is a scalar or vector. Okay, it is also a scalar quantity. Why? Because it has only magnitude. Magnitude means number. Okay, how we can represent voltage? 5 volts, 6 volts, 110 volts, all those things, the numbers 5, 6, 110, all those things are magnitude. It doesn't have direction. Then what does this plus and negative represents? Listen. Plus represents work has to be done on a positive test charge against the repulsive force. What does this negative represents? Work done should be done on the negative test charge against the attractive force. This is the meaning of positive and negative. Okay, so the inner meaning is very huge. We cannot understand it. Only those things we are going to learn in engineering, not in 10th standard. Our next question, define the term resistance, state its SI unit. See, if you have understood the concept video, this question is very easy for you. What do you mean by resistance? Whenever the current is flowing, okay, the obstruction to the flow of current or electron is called resistance, and they are asking for the SI unit, that is nothing but ohm. This is the SI unit and this is the definition. Our next question, name the particles which are responsible for the flow of current in a metallic wire. Very simple question. See, for sub question A, the answer is free electrons. Okay, then we'll go for sub question B. Explain the flow of current in metallic wire on the basis of movement of the particles named by you in the above in part A. Okay, now we have to explain how these free electrons works in a metallic wire. Listen, these free electrons, okay, movement of free electrons will result in conduction of electricity. Movement of free electrons will result in conduction of electricity. So, and this can be written as Q is equal to N into E. Q means charges, N means number of electrons, and E means the value of one electron. Then we'll go for sub question C. What is the cause of resistance offered by a metallic wire in the flow of current through it? See, if we connect external resistance, that means we need to oppose the flow of current. We want it to reduce the voltage or current, correct? But what they are asking, what is the cause of resistance in the metallic wire? We know all the metals will offer some resistance. Why they are asking? Because we know in metals we have both free electrons and also the positive ions. When the free electrons collide with the positive ions, then there will be an obstruction to the movement of electrons, correct? This is nothing but resistance. Our next question, name and state the law which relates the potential difference and current in a conductor. Okay, there is one more sub question, we'll go for it after solving this one. They are asking us to name and state the law. See, the law is Ohm's law. Okay, before answering this question, we have defined Ohm's law, correct? That is the answer for the same sub question. Next, for the second sub question. B, they are asking what is the necessary condition for a conductor to obey the law, which law? That Ohm's law named above in part A. See, if a conductor to obey Ohm's law, the temperature, okay, should remain constant. This is the main condition. Okay, if temperature is constant, the conductor will obey Ohm's law, else it will not obey Ohm's law. Our next question, give two differences between ohmic and non-ohmic resistors. See, first whenever it comes to differentiation, okay, ohmic, non-ohmic, first point always try to go for definition. Okay, first point always definition. Okay, ohmic and non-ohmic just now we have discussed. Okay, the second point will be the resistance value. Okay, the resistance value will be same for all V and I values. Okay, resistance value, if you take any two voltage and current or any other two voltage and current values, you will get the same resistance value. See, like this. If you talk about here, okay, at this point, if I take current value and voltage value, you will get one resistance value. If I take current value and voltage value, at this point also will get the same resistance value. That is the meaning of this one. And here again definition, second point will be opposite to this one. Resistance value will not be same for all voltage and current values. That's it. Our next question, figure below shows that IV characteristics curve for two resistors. Identify the ohmic and non-ohmic resistors. Give a reason for your answer. Very simple. Listen. See, this one, okay, the graph A is not linear. Correct? Is not linear. It has a curve. When a graph has a curve, it is nothing but non-ohmic resistor. Okay. The linear slope, this is called slope, right? So this is curve slope, this is linear slope, this is ohmic. This is what we have learnt in question and answer in the previous questions. Ohmic resistors. Okay, here the reason is for all the values of V and I will get the same resistance value. For all the values of V and I will get the same resistance value. For all the values of V and I we will not get the same resistance value. That is why this is non-ohmic and this is ohmic. That's it. Our next question, how does the resistance of a wire depends upon its length? Give reason for your answer. The same thing, see, this is the formula to find resistance when it comes to length and area. See how length and resistance are related, both are in the numerator, right? So they are directly proportional. That is the question they are asking, how they are related. They are directly proportional. Why? Because if length increases, resistance also increases. This is the reason. And listen, don't write like this in the exam, write it in the form of sentence. See, whenever you are writing any answer in the form of sentence, don't use any symbols like equal to symbol, greater than or smaller than symbols. All those things if you use, you are not going to get marks because you are writing in the form of statement. Statement should not include any of the symbols. Our next question, how does the resistance of a metallic wire depends upon its temperature? Explain with your reason. Okay, listen, temperature and resistance are directly proportional. Okay, this is the relation they are asking, how they are related, how the resistance depends upon temperature. They are directly proportional. Okay. What is the reason? Why? Because when the temperature increases, okay, when the temperature increases, kinetic energy of the electrons also increases. When the temperature increases, kinetic energy of the electrons also increases. They move in a random direction and collide each other. So collision is nothing but resistance, correct? So how these two are related, resistance and temperature, they are directly proportional. Why? Because if the temperature increases, kinetic energy of the electron increases, the moment of electrons will increase. They move in random direction and collide each other. Okay, instead of moving forward, they'll collide each other. The collision is nothing but resistance. So this is the reason for our statement directly proportional. That's it. Our next question. Two wires, one of copper and other of iron, are of same length and same radius. Which will have more resistance? Give reason. We are talking about resistance, okay, and they are telling length and area are same. These two are same, but which is the remaining thing? Resistivity. Okay, for iron, okay, resistivity is more compared to copper. Okay, the resistivity of iron is more compared to copper. That's why resistance in the iron is more compared to copper. That's it. See, these two, resistance and resistivity, are directly proportional, correct? So for the same material, if we are talking about two iron rods or iron wire, the resistivity remains same. But we are talking about two different materials, correct? One is iron, one is copper. Resistivity of iron is more compared to copper. That's why resistance will be more in the iron. Our next question. Name three factors on which the resistance of a wire depends on and state how it is affected by the factors stated by you. Okay, first we'll write the factors. Factors affecting resistance. First one, length. Second one, area. Third one, temperature. Okay, whenever you are writing in the exam, don't write the symbols. Write it in full form. You will get full marks, or else they will definitely deduct 1 mark. Okay, how? Okay, these are the factors affecting resistance. Now we have to state how they are affecting it. Length is directly proportional. Area is inversely or indirectly proportional, and temperature is directly proportional. So these are the factors. Okay, this is how they are affecting it. What do you mean by directly proportional? If the length increases, resistance also increases. What is inversely proportional? If the area increases, resistance will decrease. What do you mean by directly proportional? Temperature is directly proportional. If the temperature increases, resistance also increases. That's it. Our next question. Define specific resistance and state its SI unit. Okay, specific resistance or resistivity is nothing but the resistance of the wire of unit length and unit area of cross section. So this is the answer, and we have to write the SI unit. SI unit of specific resistance. Okay, specific resistance is nothing but ohm meter. That's it. Our next question. Name the two factors on which specific resistance of the wire depends. First we'll solve this one, then we'll go for the second subquestion. A. Listen. Specific resistance is nothing but resistivity. Okay, what are the factors affecting it? One, material. The second one is temperature. These are the factors affecting specific resistance or resistivity of a wire. Now we'll go for the second subquestion. Two wires A and B are made up of copper. Both are made up of copper. This is very important. Both wires are made up of copper. The wire A is long and thin, while the wire B is short and thick, okay, which will have more specific resistance. See, the important thing about specific resistance and resistivity is, if we are talking about two wires made up of same material, okay, then the specific resistance will be same. Keep that in mind. Okay, keep that in mind. So wire A and wire B, okay, whatever happens to the length and area, the specific resistance will not be changed. Why? Because the only two factors which affect specific resistance will be material, what material, and temperature. We are talking about length and area, so it will not affect specific resistance. For both wires A and B will have same specific resistance. In the exam, you should not use symbols, use full form. Our next question: how does specific resistance of semiconductor change with increase in temperature? If you increase in the temperature for semiconductor, what happens with their specific resistance? See, specific resistance when it comes to semiconductors, keep this in mind. Semiconductor, only for semiconductor, specific resistance is inversely proportional to temperature. Okay, if you increase the temperature, the specific resistance will decrease in semiconductor. We are talking only about semiconductor. This is not equal to, this is not same for metals and insulator. Okay, so if you increase the temperature, specific resistance, okay, will decrease. Our next question: how does resistance and specific resistance of a wire depends upon its length and area? We know area, radius, both are same. Okay, we know specific resistance will not be affected from length and area. So specific resistance, this is the symbol for specific resistance, but you should not use it in exam or while writing. You have to use the expanded form. So will not get affected by length and area of the wire, but resistance, okay, is directly proportional to, see, you have to write it in the form of sentence. Resistance is directly proportional to length. If the length, that means if the length increases, resistance also increases, and resistance is inversely proportional to area. So this is the meaning of inversely proportional, this is the meaning of directly proportional. You have to write it. Resistance is directly proportional to length, resistance is inversely proportional to area or radius, both are same. Our next question: name the material used for making the connection wires, give reason for your answer. We have one more sub question. First we'll answer this question. See, for connection wire is nothing but the normal wires which we use it in our daily life. Okay, listen, what kind of materials we are using? We are using copper or aluminum. Okay, copper or aluminum. Why we have to use this one? That is also they are asking. Why? Because this has a small or less, okay, less specific resistance. These two have less specific resistance. So resistance will be negligible. Now we will go for the second sub question. Why should a connection wire be thick? So what do you mean by thickness? Thickness of wire. Thickness of wire is nothing but area of the wire. Area of the wire. So if the thickness is more, area will be more. How resistance and area is related or thickness is related? See, this is the main formula. How is area is related to resistance? These two are inversely proportional. If the area is more, if the thickness is more, see the answer why it should be thick. If the thickness is more, resistance will be less. See, thickness, if thickness is more, resistance will be less. This is the reason why the connection wire should be thick. Our next question, name the material which is used for making standard resistance. Standard resistance is nothing but a resistance wire only. Okay, so which material we are using? Very simple, manganin or constantan. These two are the alloys. Okay, alloys. We are not using both, any one. Okay, manganin or constantan. Then they are asking the reason, because these two have very high okay, specific resistance. This is not the only reason, and if the temperature increases or decreases, there won't be any effect in the resistance. So if the temperature increases or decreases, the resistance will not change. Our next question, name the material used for making a fuse wire. Give a reason. Very simple. See, fuse is made up of lead and tin, mixture of lead and tin. So what do you call those as? Alloy. So alloy of lead and tin is used to make the fuse. And why? Because lead and tin, this alloy has, okay, very high specific resistance, very high specific resistance. So its melting point, okay, melting point will be low. If the specific resistance or resistance is more, melting point will be low. See why they are talking about melting point? Listen, very simple. Assume any appliances, it may be washing machine or anything, any appliances in your home or anywhere. So it is connected with the wire, right? Between them a fuse will be there. When the current is more, okay, assume this requires some 10 amperes of current. Okay, now we know we are using AC current, so magnitude, the value will not be constant, it will be changing. So because of there is a problem, assume the current will be 15 amps. What happens if we give this 15 amps to these appliances? These appliances will get damaged. What happens? So that's why we are using fuse. What happens when the current is more? The metal inside it, lead and tin, will melt. So there will be no connection between the wire and the appliances. So these appliances will be same. That's why, okay, it should have low melting point. That's why we are using lead and tin alloy. So it has more specific resistance. More specific resistance means more resistance. Then it will have low melting point to safeguard the appliances. Our next question, what are superconductors? Give one example for it. Okay, listen. What do you mean by superconductors? Superconductors are the substances having zero, okay, you have to write it in the form like this, zero resistance or very high, okay, very high conductance at very low temperature. See, using all these things you have to write it in the form of sentence. Superconductors are the substances which has zero resistance, or you can write any one or you can write both, zero resistance or very high conductance at very low temperature. This word very low temperature is very much important. Examples, mercury, okay, when the mercury is taken below 4.2 Kelvin, okay, the temperature, can you imagine 4.2 Kelvin, that means around minus 270, almost 70 degree Celsius. At that temperature, mercury acts as superconductors. Next, lead, when it is taken below 7.25 Kelvin, it acts as a superconductor. Next, niobium, below 9.2 Kelvin, it acts as a superconductor. Our next question, state Ohm's law and draw a neat labeled circuit diagram containing a battery and a key, a voltmeter, an ammeter, a rheostat and unknown resistance to verify it. Okay, first we will define Ohm's law. Listen, in 2024 we have to while correcting the board exam papers, we have to deduct marks for so many students only for this question. Why? Because this question was asked for 2 marks. First one we have to define it properly. The final statement of Ohm's law is very much important. See, the current flowing through the conductor is directly proportional to the potential difference between the ends of a conductor only if the physical conditions and the temperature remains constant. This statement is very much important. The physical condition and the temperature remains constant. I know the first statement, current and potential difference, you will definitely write. If you miss this temperature word, temperature is constant, then you will never going to get marks. Okay, the expression will be, Ohm's law expression will be V is equal to IR. That's it. Now we'll talk about the diagram. They're telling we have to use a battery. So this is a battery, right? No, this is a cell. If you add one more cell, okay, 1 or 2 more cells, then that becomes a battery. So this is a battery, positive and negative. They have told us to connect one XL resistance and voltmeter. Okay, from voltmeter to ammeter, from ammeter to a key, so from key to a rheostat. Okay, rheostat. Listen, positive, this is negative, positive, negative, positive, negative, and this will be the external resistance. Rheostat is defined as, okay, termed as RH. See, that's it. And voltmeter should be always in parallel connection. You don't, I know you don't know what is parallel and series connection. This you are going to learn in 8th B. Okay, the same electricity chapter in the next part. This is the required diagram. Our next question, draw VI graph for conductor obeying Ohm's law. What does the slope of VI graph conductor represents? Very simple. This we have learnt in concept video. That's why I am going to write it directly. See here, we have to write the graph. See, this will be V voltage and this will be I current. This is the VI graph. What is this slope represents? This slope represents resistance. That's it. That's it. Our next question, draw a IV graph for a linear resistor. What does its slope represent? Very simple question again. So instead of writing VI, we are going for IV graph. Okay, the slope remains same, but the meaning of the slope is completely different. So initially it was resistance, now it is conductance. Conductance. So conductance is inversely proportional to resistance. See, conductance is equal to 1 by resistance. Okay, so VI graph represents the slope. The slope in VI graph represents resistance. The slope in IV graph represents conductance. That's it. Our next question, what is an ohmic resistor? Give an example for an ohmic resistor. We have to draw a graph. First we will solve this one. Listen, what are ohmic resistors? See, ohmic resistors are nothing but the conductors which obeys Ohm's law. Okay, conductors which obeys Ohm's law are ohmic conductors. Give an example. All metallic conductors such as silver, okay, silver, copper, aluminium, all those things are examples for ohmic resistors. Now we'll go for the next diagram, the graph related question. Draw a graph to show current and voltage relationship. Okay, how is the resistance of the resistor determined from this graph? Listen, this one we have solved. This is the relation between voltage and current graph. The resistance will be determined with the help of slope. That's it. Our next question, what are non-ohmic resistors? Give an example and draw a graph to show its current voltage relationship. Okay, listen, first we'll understand what are non-ohmic resistors. The conductors which will not obey Ohm's law are called non-ohmic resistors, and this is the graph for non-ohmic resistance. Okay, listen, in ohmic resistors, okay, the graph will be linear, it will be straight. Okay, but in non-ohmic resistors, okay, the graph will not be straight. So this is a graph for non-ohmic resistance, that is nothing but current and voltage graph for non-ohmic resistors. And few examples: LED, solar cells. Okay, these are the examples for, and you can talk about diode also, specifically junctional diode. Okay, don't worry about this diode and all, because you are going to learn this one in PUC. Now these are the examples for non-ohmic resistors. Our next question: draw a VI graph for a conductor at two different temperature. What conclusion do you draw from the graph for the variation of resistance of a conductor with respect to temperature? Okay, listen, first we have to draw VI graph. So whenever they are asking VI graph, just write like this. Okay, VI. Okay, we need to write, okay, conductor with two different temperatures. See, the same conductor, first I'll write it like this. Okay, we'll write this one as A, and the same conductor, okay, we'll have it as B. Assume this as T1 and T2. See, we need to know the basics of conductance and the temperature. What happens when the temperature increases? Listen, whenever the temperature is increased in the conductor, whenever a temperature increased in the conductor, the kinetic energy of the electrons will be faster. Okay, they move in a random way and they collide each other. Collide each other means that is nothing but resistance. So in the first slope A, okay, in the first slope A, temperature is low. Temperature is low, and in the second slope B, the temperature is more. That is why the temperature, okay, the slope B has more temperature. More the temperature, more will be the resistance. See, which line is near to the current? This line, right? So this has more current compared to this one. That means it has less resistance. This has more resistance. We are talking about the same conductor with two different temperature, low temperature and high temperature. When the temperature is high, resistance will be more. If the resistance will be more, then the current will be less. Our next question: how does the resistance of a wire depends upon its radius? Explain your answer. Okay, listen. First we'll write the formula. R is equal to rho L by A. In this formula, do you find radius? No, right? So radius is hidden in the area. So I can write the same formula in terms of, see, in terms of, instead of writing area, what is the area formula? That is pi r square. Why we are using pi r square? Whenever we talk about any conductor, see, this is the thickness we are going to talk about. The thickness, this is in circular shape, right? So that's why we have taken area as pi r square. So this is the radius. Now see how radius is related to resistance. These two are inversely proportional. Inversely proportional. Inversely proportional, or you can write it as indirectly proportional. Okay, this is the answer they required, and explain your answer. Listen, if radius, okay, radius increases, see the explanation I am going to give. If the radius increases, resistance will decrease. If the radius increases, resistance will decrease. That is the explanation they required. Now we'll go for the second sub question. Two copper wires of same length, but one is thicker than the other, which will have more resistance? Assume. Now we'll talk about second sub question. Okay, there are two copper wires, one is thicker than the other. Okay, if thicker than, if assume this is A and this is B, copper wire, both are copper wires only. This is thicker compared to this one. Now more the thickness, more will be the area, correct? More will be the area. See how these two are related? Area is inversely proportional to resistance. So more the thickness, less will be the resistance. So what they are asking, which will have more resistance? See, if area is thicker, resistance will be smaller, correct? More the area, less will be the resistance, because these two are inversely proportional. Then the tin, okay, tin copper wire will have more resistance. That's it. See, if the wire is thin, okay, it will have more resistance. If the wire is longer, okay, if the wire is longer also, then also, see, if the length is more, resistance will be more. If the thickness is nothing but the area, if the thickness is more, resistance will be less. Now we have solved each and every theory question from the electricity part A. So we have learnt till now, we have learnt the concept video, okay, we have seen it and learnt it, and we have solved each and every theory question. How much we have learnt about part A? We have learnt only about 50%. Remaining 40 to 50% we are going to learn from solving the numericals. That video is also available in the description box. In any chapter you have to learn all the 3 parts. Concept video, you are going to learn the concept, we are going to solve the theory questions, then we are going to solve all the numericals. If you know all these things, then you are almost 90% ready for the board exam. 10% application oriented questions. If you have this much knowledge, I believe aram se you can solve any application questions. Thank you.